Okay, so we've just finished part A2. Now it's on to part A3. And we have some information there initially about how it can be very important that you don't waste any chemicals for a variety of reasons, one of which is cost, right? It's also important to learn how to measure out things quickly because anybody can follow a recipe. It's not whether you can follow a recipe, it's the time is always a factor in life. So, how long it takes you to do the following, all right? So, we're going to get a stopwatch, right? Stopwatches will be over here on this cart. Get a stopwatch, and we're going to time how long it takes you to do this, right? So, start the timer, weigh out 0.242 grams of copper sulfate, add 2 milliliters of water, and then stop the timer. And we don't need the solution to be completely mixed, right?
Right.
So we're just going to follow that recipe and then stop the timer.
Right.
Now the second one might be a little more confusing, so that's the one we're going to perform here. The first one's pretty straightforward. The second one says start the timer, weigh out any number of grams of copper sulfate between 0.121 and 0.484 grams, and then calculate how much water should be added by solving the ratio below there. Oh man, the lines got shifted in this. So, we'll get a weigh boat, correct?
Correct.
You still have a... All right, so we'll time you. Ready? So you're going to weigh out between 0.121 and 0.484, right?
Right.
So go ahead and put that on the balance. Tear it. Ready, set, start. Well, get your bottle open. And then we can start the clock. Ready, go. All right, so it's easier to weigh out 0.121 to 0.484 as opposed to exactly 0.242, right?
Right. A lot easier.
All right, so we have the mass, 0.249.
So,
0.249. So how do we manage that mass now?
can just take 0.249 divided by 0.121, and that should give us the number of milliliters we need to use.
Okay. So 0.249 divided by 0.121. We have to perform that calculation.
0.249 divided by 0.121 equals about
2.057. Okay, why don't you divide that by 3? All right, so 686 microliters. So you have to add 686 microliters 3 times, correct?
correct.
So there's that. We need a tip. There we go. So that's an easy way to weigh out or measure out that much mass or volume. So we're going to add that much volume. 1, 2, 3. Very good. And then that would be time to stop the clock. Okay? So we'd have to stir that up and wait for it to dissolve. But we want to compare how long it takes to do that one to how long it takes to do this one. And the second one here, if you're careful with weighing it out, there'll be absolutely no waste. Whereas the first one, every time you go over 0.242, you have to make sure that you don't put that back into the bottle. You put it into a different container for maybe the next steps if it's necessary. All right, so we finished part A1, 2, and 3, and now we're on to part B, correct?
Correct.
All right, what do we do in part B?
We're simply making one solution of ethanol and water, making a 50% ethanol solution. We're not going to go about that any particular way. This is for your own benefit. Just take 25 milliliters of water, 25 milliliters of ethanol, mix them together, see what happens.
Okay, and we don't want to give away the surprise, right?
Right.
So we'll let them do that. And on the table, there should be alcohol for you to use, so this is where you'll get the alcohol. Now, excellent. Okay, so that will be part B. Now we're on to part C, the last part. What do we do here?
Here we're going to make a few solutions of ethanol, 20% solution, a 40% solution, 60%, and 80%. Then we're going to measure their density and make a plot of this density, of the densities of each solution. Then you're going to calculate, using the trend line that you get from that plot, the expected density of a 30% solution. Then you're going to make that solution and compare it to your calculated value.
Okay.
Finally, I'm going to give you an unknown solution, or your professor, teacher, is going to give you an unknown solution, and you're going to determine the concentration of that solution.
All right. So how do we make, like it says here, 10 milliliters of, let's start off with the 20% volume ethanol. How do we make 10 milliliters of that?
You would measure out 2 milliliters of ethanol, put that in something that can measure out 10 milliliters, and then fill that up to 10 milliliters.
Okay. So like our 10 milliliter volumetric flask, would that be good?
That would be perfect.
Let's see, where is it? We have one. There we go. So, what's that? Oh, that's only 5? Oh. Where's the 10?
Here.
Found one? Excellent. All right, so we have the 10 milliliter volumetric flask. You said put 2 milliliters of ethanol in there. Probably best to do that with a micropipette, right?
Right.
2 milliliters of ethanol, and then you just fill it up to the line with water, right?
Right.
Okay. And then,
After that's done, make sure it's shaken real good.
okay, why don't we do that really quick? So here we have some ethanol. Two mils of ethanol.
Then
Let's see, where's the dropper? Do we still have the dropper?
not quite. I think I threw that one away.
Okay. All right. Another dropper.
Use a dropper to do the last little bit.
Right to 10 mils, right?
Right.
Excellent. Then like you said, we need to mix well now, correct?
Right.
Now, how are we going to determine the density of this solution?
Like in the first lab, you should just take 1 milliliter. You can use a micropipette, pipette that out onto a weight boat on a scale, and measure that 4 times.
Okay. Find its mass,
per 1 milliliter.
compare that to the volume, and have the density. Excellent. So, we're going to determine the density of the 20% ethanol solution. Now, how would we make a 40% ethanol solution?
4 milliliters into a total of 10 milliliters.
Okay. All right, so we do that with the 20, the 40, the 60, and the 80% ethanol solution. We find their density, and then how would we plot that data on our Excel? Or how would we treat that data?
We would. Should we actually maybe?
Yeah. So what is it we're going to be doing?
we're going to make a scatter graph, a lot like you did with your density of water and ethanol. This time though, the independent variable is going to be the concentration of ethanol. So the concentration of ethanol needs to be on the x-axis.
Okay.
Pull up Excel.
All right, so
we're going to do a 0%, 20%, 40%, 60%, and 80%. And because we know the density of 100%, we can throw that one in there too.
all right. So the density of the 0% solution is essentially the density of water because there's no alcohol in it, right?
Right.
Okay. So that's percent ethanol up there, or you're gonna? Okay.
Yeah. Well, make sure you label your graphs.
Okay.
Then
Density. And this one was about 0.998 for, that's what I got in my lab at least.
yes,
Is that okay?
that's what I got too.
Okay. 20%, let's say the 20% was about 0.965. Whoops,
Oh, not 965, 0.965.
for the 20% though, right?
Right.
And the 40%, 0.890. And the 60%, 0.850. And the 80%, 0.80. And the 70% or 100%, 0.776. Okay, so this is some possible numbers. You might not get those exact numbers. Those are just numbers that we made up based on our experience. So let's say, and you found all those densities of all those percentage of ethanol solutions, and now what do we do?
We highlight it,
Mm-hmm.
go insert, scatter graph, and we'll get a graph that we can make a linear, or get a linear fit trend line
Okay.
like that. So get a trend line, make sure it's linear, make sure we have the equation displayed on the chart.
All right. Now, how is that equation going to be helpful to us? Why do we want an equation here?
Remember that the percent ethanol is on the x-axis. So for the 30% ethanol,
What do you mean the 30%?
the calculated 30% ethanol that you're supposed to find.
Oh, yes. It says from the data in step 2, predict what the density of 30% ethanol solution would be. Take 10 mils of 30% ethanol solution and determine its density. 10 mils of 30% ethanol solution and determine its density to test your hypothesis. Okay, so we can now predict the 30%. Would it be appropriate just to take 20 and 40 and find the average between them to predict the 30?
No. No, we have this formula, we should use it.
Okay.
Since we know that the percent ethanol is on the x-axis, we can just plug in 30% into x and solve for y.
Okay, so why don't you show them again how to label our axes so that we get a refresher on that.
Okay, make sure we go to Chart Tools and go there.
Okay.
And then over here,
Density in grams per mil, right? Capital L.
right.
Excellent. Okay. So, you're saying, oops, we lost our equation when we did that. Put it back in there. So you're saying that we can predict what the mass or the density of a 30% solution is by putting 30% into where?
Into X.
Okay. So if we put 30% into X, it'll tell us what the Y value would be and thus what the density of that solution would be.
Right.
And then we're going to make the 30% solution, right?
Right.
And see how close we are.
Exactly.
All right, well, after we make that 30% solution, we'll be able to insert it right into here, correct?
Right.
All right, so let's say we predicted, or we did well, let's see, let's put it in here. What would it be? We can do that, right? By just making a little equation here and taking the value 30, right? Multiplying it by
Negative 0.0024 and adding 0.9973.
okay. Okay, so it predicted it would be 0.9253. All right, so we put that in there, and it changed our line slightly, but that's all right. Now we don't put the predicted one in here, right?
Yeah.
We would actually put the one that
We find.
we would find, but that's good enough. Right? For us, we'll do that. Okay, so now we have quite a few points on here, and now what's the next step?
Now I'm going to give you an unknown solution, or your professor or teacher is going to give you an unknown solution. You're going to measure the density of the mass of 1 milliliter, put that in for Y, solve for X to find the percent solution.
Okay. So it's an unknown solution that contains some ethanol in it, but we don't know what percentage of ethanol it is.
Exactly.
We're going to find its density, put it into the equation for the density is on the y-axis, so we put it into the y here, and whatever X spits out, that should be the corresponding X, or the percent ethanol. All right, that's good. Is that all we have to do?
That is all we have to do.
Excellent. All right. Good luck on your labs, right?
Good luck.
Thank